Welcome to The Explainer. Today, we're diving into one of the biggest frustrations for AI engineers. Why your AI agents are so darn unreliable and, more importantly, how you can actually fix them for good.
So, you've poured hours, maybe even days, into building an AI agent. It's supposed to connect to some external tool or an API to do something genuinely useful. But when you hit run, it just doesn't work consistently. Sound familiar? It's a super common story, and yeah, it's incredibly frustrating.
All right, let's get into the nitty-gritty of the pain you're probably feeling. It's not just random bad luck. The ways these agents fail usually fall into a few very specific and very annoying recurring patterns.
Does this look painfully familiar? The model spits out completely broken JSON. It just makes up arguments that your function has never even heard of. Or, and this is my personal favorite, it just silently fails, kind of pretending it did the work. If you've spent a whole afternoon debugging any of these, you know exactly what I'm talking about.
So here's the thing you have to understand. This isn't happening just because you wrote a bad prompt. There's a fundamental conflict, a clash, baked right into the technology we're using. And getting a handle on this conflict is the absolute first step to solving the problem.
Here it is, the heart of the problem. On one side, you have this large language model. It's creative, it's flexible, it thinks in shades of gray and probabilities. And on the other side, you have a machine API, which is rigid, structured, and totally unforgiving. It needs perfect syntax every single time. We're trying to force these two complete opposites to have a perfect conversation, and, well, that's where all the chaos comes from.
So how in the world do we bridge this gap? We have to bring some order to that chaos. And the solution isn't some magic prompt you can just copy and paste. It's a structured, three-layer framework for building your entire agent interaction from the ground up.
And here's how it works. Think of this as your new game plan for building reliable agents. We start with schema engineering. That's our blueprint. Then we define the rules of the game in the system prompt. And finally, we build a safety net with a verification loop. Each layer builds on the last, making the whole thing incredibly robust.
Okay, layer one. The foundation of this whole thing is the schema. You have to forget about just describing what you want in plain English. Instead, you give the AI a non-negotiable blueprint using a strict data structure, something like a JSON schema or a pedantic model. This basically tells the model, hey, your output has to look exactly like this. No exceptions, no creativity.
Now, once you have that blueprint, the system prompt becomes your rulebook. This is where you lay down the law for the model. You tell it you must follow the schema I gave you. You tell it how to handle errors, what its main goal is. It's all about setting clear, enforceable boundaries for its behavior.
But what happens if, after all that, the model still messes up? I mean, it's going to happen. That's where our safety net, the verification loop, comes in. You build a little process that checks the AI's output. If it doesn't match your schema, you don't just let it crash. You actually send it back to the model with feedback, basically saying, nope, that was wrong, and here's why. Now try again. It's self-correction, built right into your system.
All right, so this framework is great in theory, but how you use it in the real world really changes depending on the model you're working with. You have to remember, these different models have their own little quirks and personalities.
And you absolutely have to adapt your style. For something like GPT-4o, just be direct. Concise JSON is king. But for Claude 3.5, you'll get way better results if you wrap your instructions in XML tags and encourage it to think step by step. And with Google's Gemini, you've always got to be careful of its pretty strict safety filters, which can sometimes get in the way of your tool calls.
Now, what happens when your agents get more complicated and have, say, a dozen different tools they can use? Well, you need a traffic cop, and that's exactly what the router pattern is. It's basically a preliminary call to the LLM that acts like an intelligent switchboard operator. It looks at what the user wants and decides, okay, for this, you're going to need tool A, and then you'll need tool B. This is absolutely essential for building more sophisticated, multi-step agents. You know, mastering this framework for reliability isn't just about fixing the bugs you have today. It's really about building a solid foundation for what's coming next, which is a major evolution in how AI interacts with our digital world.
See, we're on the edge of moving beyond agents that just call these nice, clean, structured APIs. The next big frontier is something called large action models, or LLMs. These are agents that can literally look at a screen, understand an application's interface, and control it directly, just like a person would, by clicking, typing, and navigating around.
This quote really just sums up the whole journey perfectly. The techniques we've talked about aren't just little patches or workarounds. They represent a fundamental shift in how we have to think about designing and building AI. You're moving from this world of frustrating, chaotic errors to one where you can engineer clear, reliable, and seriously powerful agents.
So, we've kind of cracked the code on making agents actually work. We can make them dependable. But that technical solution opens up a much bigger, and I think, more profound question. Now that they can do things reliably, what should we trust them to do? That's the real challenge that's waiting for us just around the corner.